Hi there. This is Mike Amundsen. I'm coming to you from Kentucky today. This is a recorded session. I'm sorry I can't actually be with you live. I'm on a tour right now, and if I remember correctly, based on what day it is for you, I think I'm somewhere in New Zealand or Australia or somewhere in the Pacific. I'll be spending 3 weeks out there visiting lots of companies, talking about APIs, and meeting with customers throughout the Asia area. So I can't be there in person. I apologize, but I know you've got lots of really talented folks there that can help answer any follow-up questions that you have. I'm also looking forward to being in Latin America later this year, I think actually this spring in March and April, and hopefully I'll get a chance to meet some of you then. So in this short video, I wanted to talk about a couple of things that I think are pretty interesting that we're seeing happening in the API community, things that you're probably already seeing yourselves, and that will affect the way we think about development, operations, security for the next several years. So really 3 things I wanted to focus on. First one is this idea of DevOps. We've heard lots and lots about DevOps for several years, and now it's really starting to become sort of a basic thing that we need to do from the beginning. Almost the cost of entry, the ticket you have to pay just to begin is this notion of DevOps. Well, DevOps has been around for a while. It was about 8 years ago that it first began. So what are the lessons that we can learn from what's happened in the 8 years since we first started thinking about DevOps and how it's affecting organizations today? How can we take those? We'll have 4 lessons we want to talk about. And how can we take those and turn those into something that we can apply in our own shops today? So the lessons of DevOps. Now, right on the heels of DevOps, we're getting another round of discussions about the way we write code. DevOps, remember, is mostly about ops. It's mostly about automating everything that happens once we check in code. So we check it in, we test it, and we put it into production. So what happens before check-in? The word that's coming up that people are using about this experience is microservice. Microservices really have a lot of the same features, the same notions as the DevOps lessons, but they're slightly different, and they're applied in different ways. There are certain things we can automate in code and certain things we can't, but we can optimize several things. So we'll talk about the promises of microservices. Then finally, I wanted to talk about what I call the API ecosystem challenges that we're going to be facing over the next several years. As we begin to apply these DevOps lessons to code, as we start to combine this operational experience with the experience for development, we're going to be faced with several changes to the way the ecosystem of APIs work. That ranges from security to monitoring to just the basic way we interop with each other. Internet of Things has something to do with this, but it's a much bigger issue than that. Even if you're not into the Internet of Things, you're going to be facing these challenges. So what are those? How are they going to affect the way we want to design code in our shops, the way we want to implement and maintain, and where we want to put our focus in the next several years in terms of skills and tools and investments? So those 3 things, this idea of DevOps lessons, Microsoft promises, and ecosystem challenges, I think are the things I wanted to focus on today. And hopefully this will give you some ideas about what you can start to think about, how you can start to apply these ideas, and we'll briefly touch on some of the software and hardware that you want to think about investing in this period. So let's talk about the first one, this idea of DevOps. So DevOps has been around for about 8 years, almost 10 years now. Originally, it was started with the notion of Agile IT, Agile infrastructure. Infrastructure people were looking at the way Agile was working. Agile's been around for about 20 years. So the way Agile was working and saying, hey, can't I have some of that? Let's do some of those things. So a lot of what started as DevOps was mostly attitude, mostly culture. Let's start to ask some really hard questions. Let's start to ask why. Why are we doing this? Why are we doing this in this certain way? Why is this important? What ceremonies are we engaged in that we don't really need to be engaged in anymore? Why don't we stop doing that? What are the things that are really important? What are the things that really make a difference? Now, a lot of this agile movement, and so far DevOps as well, is influenced by the lean concept or the lean movement that comes out of the Toyota projects all the way at the turn of the century. So in the 50s and 60s, Toyota builds this system where they start to change the way production works. They change the way production works because they focus on, for example, one of the ones is the 5 whys. Keep asking why until you get to the root of the problem. Other things that are really important in lean is this notion that anyone can contribute, anyone can stop the line in the sense in a production service, anyone can add contributions, everyone is a part of the same plan and we're all working together. We won't get too much into this lean space, there's lots of material you can focus on, but this is also a big influence as well. So DevOps comes out of this notion of agility and lean and starts to apply it to operations. The easy examples that we can think of for DevOps are things like virtual hardware. You virtualize the hardware. So we started with this notion of creating these virtual machines. So AWS, Amazon services, Microsoft, all offer these virtual machines. There are lots of products that have come up out of this notion of virtual machines, but it's now gone past virtual machines. So the next thing, by virtualizing hardware, we start to virtualize the software, the testing service as well. So now we run automated tests. So now we have this ability to run tests as soon as we check in code. So tests are no longer human-centric or resource-intensive experiences. We simply run the tests and walk away, and we wait to see what the test results are. And then we begin to automate the process of deployment. So this process of deployment is now also not necessarily human-centric. It can be highly automated. So we have deployment scripts, we have deployment VMs, we even have this notion that if it passes a test, if it goes all green, it deploys right away. So we don't even have these handoff experiences anymore. So the people who create the code, check it in, start the test, and that automatically ends up into some part of production. We also start to automate the notion of production in the sense of changing it into zones. So I have the early adopter zone. I have all sorts of zones where I can place code. So we don't actually, in many cases, blow the same code out to every single user at the same time. So we have this notion of canary builds, the idea that we build a certain new product, we put it in place in just a small community, we monitor it, make sure it's not causing us any problems. As long as it's not causing problems, we start to roll it out to a wider community. So one of the patterns that you start to see in this DevOps space is making lots of small changes over a period of time. So we start to virtualize the hardware, we start to virtualize the testing, we start to virtualize the deployment, we start to virtualize the zones in which things get deployed, and inch by inch, step by step, we make improvements. And this is a key characteristic from the DevOps lesson space. The way you get constant improvement is through very small changes, not very large changes. One of the things we say often in the API Academy is we say, no big bets. You don't bet the company on one design, on one model, on one set of code, on one release. You have lots and lots of tiny ones. There's lots of lore around this, lots of anecdotal evidence. Etsy Corporation is a great example. So Etsy really buys into this notion of canary builds and lots of small changes. So Etsy does an average of 10,000 or more releases a year. That's a huge amount of releases, and if you actually go back and you start to look at what the release types for Etsy are, a lot of them are configuration releases. They're not code releases. So they're starting to build code that gets configured in lots and lots of ways. Configuration releases are a much lower risk than code releases because you're not changing runtimes, you're just changing the sort of the state of things. You're changing the switches that you turn on and off, which is an incredibly important idea. Amazon just did a talk recently where they said when you count every bit of configuration, every bit of code, every change over every one of their products over the entire world, in the last year they made more than 5 million changes to production. So those are 5 million very, very tiny changes, very, very small changes over a long period of time. So this is an incredibly important idea. This is an incredibly important lesson from DevOps, and that is small changes over a long period of time. Now, there are other really important changes in DevOps, and I kind of boiled them down into four basic things. That is what we learned about cost, speed, resilience, and visibility. So sure, we use DevOps a lot for cost reduction. DevOps can really reduce the amount of time and money it takes to get something out the door. So once I have this notion of very small bits that I can move very easily, then the cost of making a change to a production application lowers a great deal. When the cost lowers a great deal, I'm more apt to do it. I'm more apt to try it. If a customer says, it would really be better if this screen was a little larger, if this routine had a few less steps in it, if I was able to customize in these ways. If it turns out that that customization or that modification is incredibly expensive, then I'm going to say no to that because I really don't want to take the risk and spend the money. But if I can reduce the cost of that operation, suddenly it becomes incredibly easy and incredibly simple and much easier for me to do. So reduced cost is an important lesson in the DevOps space. And that really falls into the speed lesson that comes from DevOps. One of the things that we learned from DevOps is they could reduce the speed from the test to deploy. I can deploy more things more often. The time it takes for me from when you want to put it into place to when it appears in place gets shorter and shorter. And that's what a lot of virtualization is about. Matter of fact, the whole virtualization of machines down to the container level, Docker and other things, is all about actually increasing the speed even more. That's really an optimization. So now Docker and containers and these other things like this let us increase the speed of deployment from 20 minutes to a matter of seconds. And that's incredibly important. So DevOps lets us reduce costs. It also lets us increase speed. But one of the important things about DevOps is it doesn't risk resiliency or stability. We actually get to improve resilience. Now, this improved resilience doesn't come just because we're doing things faster or cheaper. It comes because we've designed them differently. So what DevOps taught us to do is design things so that it's hard to knock them over. It's hard for them to crash. There are some very simple ways to do this. Using more and more stateless components, simple components that do one thing and one thing well. It's difficult to break those because they only do one thing. The complexity is much lower. The second thing that happens in the DevOps space is because the cost of deployment and the speed of deployment is low, I can place dozens of the same machine or dozens of the same operational bit of code into production at the same time. So there's not just one login machine anymore. There's now a dozen login machines. Now, if one of those machines happens to go bad for one reason, whether it's a hardware or software problem, I've got 11 other machines that are still running, so I'll barely notice it. This is a commoditization of the notion of the software that's running on a machine. Just as we commoditized hardware, just as Google and Microsoft and Facebook actually worked very hard to make a piece of hardware cheap, a 1U very cheap, and just throw it away if there's a small problem, we're starting to do the same thing with code. If the code's not working, I'm just going to go ahead and throw it away and put another one in place. So this notion of resiliency is incredibly important. There's a lot of talk about this idea of the Phoenix server, the server that I could just bring up, and if it doesn't work, go get the other one that used to be in place. This is all about resiliency. So this cost and this speed gives us the opportunity to create a much wider space to run on. I have many more machines now, and that means that I've actually improving the resiliency quite a bit, which is very important. The fourth item in the DevOps lesson is this idea of visibility. And in fact, DevOps is having a real challenge with this fourth item. As I increase the speed and increase the resiliency by creating more instances, I need much better visibility. And visibility is a real challenge for the DevOps community right now. It's hard for us to know how many machines are in place, what they're running, and how they're interacting and how they're connected. So there's a lot of effort right now in the DevOps space to optimize the visibility, improve monitoring and managing. I talked to several customers over these last several months about what they're doing in this space, and I'm hearing stories that, we have hundreds of machines and I'm not sure what they're running. We have several versions of code and I'm not sure which ones are interacting with which other ones, and it's hard for me to manage. So this is going to be a huge challenge. If you're primarily focused in the DevOps space right now, this is the opportunity. This is the challenge. For me, challenges are always opportunities. So the opportunity is visibility. How can I improve the visibility? I'm seeing some very interesting technology that has to do with this idea of creating clusters of information, the ability to drill down to get more specific. But as we improve the resiliency and expand this DevOps model, the visibility challenge is going to be really, really big. So cost, speed, resilience, and visibility. These are the lessons of DevOps. Now what's really interesting is these start to dovetail directly into the way we design code. And designing code has not really been an emphasis in the DevOps space. It's been mostly from the time we check in code until the time it's in production. So the way we're starting to focus on this pre-check-in moment, the way we design systems, the way we code them, the way we organize them, has to do, it's being called microservices. So microservices is really a direct outgrowth of the DevOps space. And microservices promises a great deal. Microservices promises us the ability to create more resilient code at lower cost in a shorter amount of time. And that's always been incredibly difficult, especially at the enterprise level, because we have huge organizations with lots of moving parts. And creating software quickly tends to be incredibly difficult. So there are also 4 things that we are seeing occur over and over again in organizations that are focusing on these microservice promises. And that is the way they organize their teams, the continued emphasis on agility. Remember, DevOps actually comes from the notion of agile, which is 20 years ago. The increased use of systems thinking. Remember I mentioned earlier about this notion of resilience means I have lots of machines running the same code. All of a sudden, I'm not really interested in just one machine or just one code component. I'm interested in a series of them, a collection of them. And that means systems thinking. And finally, to really kind of wrap this part of the microservice promise space up, there's this notion of product focus. We've heard a lot about you need to focus on your products. You need to focus on what's going on in a particular product. So let's go over each of them. Under the microservice space, we really have this notion that we have small components that do one thing and one thing well and interact independently with other components. And one of the first ways that you start to get cohesive small components is through managing your teams. There's a thing called Conway's Law, which was first written about in the 1960s, in the late 60s by Mel Conway. And it's the notion that the way you organize your teams affects the way you produce code. We won't have time to go into a lot of it, but even recent research from Microsoft, example, about the way they organize their teams. Team communication, team organization is actually a better indicator of the quality or the bugginess of code than any other measure. Lines of code, number of changes, so on and so forth, is still not as good a predictor as the way you organize your teams. So a lot of what's happening in microservice is changing the size of teams. There's a lot of sociology involved in this. This gets a little squicky for people who they're engineers, they don't really want to talk about individual items, but I can tell you from experience that the team size of 5 to 15 is turning out to be an optimal team size for producing good code. We know this from sort of the startup world. If you start in a very small group, you do very, very well. Usually that's a span of 5, a sort of a squad. Spotify calls them squads. As you get larger, you have to introduce some kind of overhead. We usually call it administrative or some other kind of phrase like that. And that starts to make it tougher. 5 to 15 is an optimal size for teams. And when you have that size of team, you really increase the next element, which is agility. The ability to talk to each other, the ability to understand what each of you are doing, the ability to say, well, let's do it a slightly different way and see what happens, all comes from this team size. So focusing on agility is still incredibly important. It's important for us to be able to make a change without a lot of ceremony, without a lot of permission. And if I have to go up a long chain of command before I can make a small change, then those changes are simply not going to happen because their cost and effort is way too high. So it's really important to continue this notion of agility, continue this notion of autonomy inside a team. There's a lot of work done in this area to create these kinds of, it's called scalable agile framework. There are lots and lots of other elements as well, but agility is really, really important. Now, once we're managing our team size and once we're giving them that autonomy and agility they need in order to solve problems, what happens with high-level organizations is you have to start thinking in a systems sort of way. You have to stop thinking about the individual teams and about what they're doing and think about how the teams interact with each other. And this is really referred to as systems thinking. If you think about the World Wide Web is a system. It's a web of lots of independent servers talking to each other. Think about what it takes to make that work. And for the most part, it operates on a very different set of rules. System rules have to do with not if, then, else, but simply when. When this happens, do this. And when becomes incredibly important in the way we start to think about the future of creating systems. We'll talk a little bit about that in our ecosystem challenge. But systems thinking also means that it's really important to make sure that I understand how the system works in general. This goes back to visibility issues. It isn't just important that I understand a component. It's important that I understand lots of components. And systems thinking is what helps you increase resiliency. There's a great book by an author by the name of John Gall. It's called Systemantics. Systemantics is this notion of the study of systems and how they behave. He's got a great line. He basically says, resilient systems continue operating even under failure mode. So even when things are failing, the system still runs. That's why we went back and talked earlier about DevOps lessons. Resilience is the ability to add lots of machines, and when one machine goes down, the rest of them don't go down. And that's really the product of systems thinking, and that affects the way we write these microservices, these little tiny services. We reduce the chance that when one stops working, the rest will stop working, and that goes back to that notion about big bets. Finally, the other big lesson that comes out of this microservice space is this notion of a product focus. Product focus usually gets explained something like this. Everybody who's in charge of a product works on the same team. And that happens from design to implementation to maintenance, from the data side, the middleware side, the UI side. They're all on the same team. This is kind of an oversimplification, but the notion that's really important is the idea of what is your product. Very often we think about IT, it's in large organizations as simply a back office cost center. It's not really an opportunity for products or opportunity for revenue, but we still need to think about them as a product. Our product is to improve the lives of sales. Our product is to improve the ability for marketing to do their job. Our product is to make sure that HR and lots of other parts of our organization have all the accurate information they need. So thinking about what your product is helps you set up what's called a boundary. There are these things called system boundaries or bounded context when we talk about software, and it comes from this product focus. It isn't just a product that you put on the shelf. It's a product that you provide inside your own organization. So organizing your teams, keeping them agile and giving them autonomy, starting to think about the overall system and make sure that it's resilient and that it can continue to run even when things fail, and starting to think about setting boundaries based on the product that you offer, even if it's across team, if it's within the organization. These are the promises of microservices, and they parallel a great deal with the notions of DevOps. So DevOps and microservices. We've had lots of history with DevOps. We're starting to see several of our organizations start to focus on microservices. And that leads to ecosystem challenges for the API space in the coming years. So there are lots and lots of challenges. It's very similar. It's always something about security. It's always something about tooling. It's always something about interop. But these continue to be big issues, and I think they're affected a great deal by what we've seen in the last 5 to 10 years in this DevOps and microservice space. First of all, we continue to focus on security. As we have more and more small components, as we have faster and faster releases, security becomes incredibly important. And security is no longer allowed to be a blocker. In other words, we can't wait for security any longer. Security has to be part of the system itself. This goes back to system thinking. And security can't always be just proactive. In other words, we can't say we're not going to let somebody do something until we turn a switch on. We're going to have to do more and more reactive security. A great example of reactive security is this notion of profiling. Profiling people's behavior and understanding what they're doing, when they're doing it, and where they're doing it in order to get a profile as to what's safe and what's not. Great example of this is with phones. I have a phone and I make a payment, a credit card payment with my phone from one location, and then all of a sudden 5 minutes later I make another, there's another record of an authorization of a payment thousands of miles away using the same phone. That's obviously incorrect. I can react to that security situation and place those elements on hold. So this is really this notion of getting a profile, getting a behavior, and getting some kind of perspective on the way people behave. Behavior-based security is going to be incredibly important. Another thing that's going to be incredibly important that we talked about already is this idea of monitoring, the idea of knowing what's going on. Knowing the context of what happens inside an organization, what happens inside your software. These records come from this location. They come at a certain pace. I know exactly what the health of the system is. How come all of a sudden our sales are lower? Is it just because nobody's buying, or do we have some kind of bottleneck somewhere? So increased attention to this notion of monitoring and creating monitoring tools that let you drill down into specifics and then come back and look at a wide range of elements is going to be incredibly important for our ecosystem challenge. And then the other big one that I really see coming is the challenge to interoperability, the challenge to orchestration. As we build smaller and smaller parts that must organize with each other, that must move in different ways and connect, the classic theory of orchestration, this idea of where I have this orchestration layer that gives me this chance to sort of create a workflow pattern that goes from here to here to here, and if does this, then this, then this, that's not going to work. It's not going to scale. It really breaks up our resiliency and introduces lots of fragility into the system. What we're seeing happening more and more is creating tools that simply say when a message comes by and it looks like this, I want to perform this step or I want to route it in this way. Amazon Services has this idea called Lambda, where you basically write very small code and it acts just in this way. When a message comes along that looks like this, execute this one bit of code and that's all. There are other commercial products out there. If this, then that is one. Zapier is another. There are several other challenges coming up as well. They're all based on the notion of no longer writing linear orchestration code, but instead writing reactive code. You may have heard about the notion of reactive services or reactive programming. This is all based on the idea of changing the way we think about interop and orchestration. So this is going to be incredibly important. Gateway services, the ability to route, the ability to inspect the message, inspect metadata, and react accordingly is going to be incredibly important. And this is going to change the way we think about middleware inside organizations, inside enterprises. If you have a heavy investment right now in orchestration, you're going to want to start thinking about how all these things that we've talked about today, DevOps, microservices, how they're going to affect that model. Finally, as you start to build smaller and smaller pieces, the ability to connect them becomes incredibly important. In the past, we've had lots of ceremony around the notion of interoperability. As a matter of fact, we don't use interop for the most part. We use orchestration. We actually use orchestration and integration. So you have to actually write the apps to talk to each other. This is going to be an incredible blocker in the future on cost and speed and resiliency. So what's going to happen is people are going to be starting writing generic components that have generic plugins, and they're all going to interop independently. And you're not going to be asking permission to connect Salesforce to SAP anymore. It's simply going to happen. And you're not going to have to write a lot of code anymore to do it. You're going to use simple plugins, simple design and draw tools. So this notion of interop and orchestration is going to really be a big challenge. This is where the people who get ahead of this curve are going to be incredibly advantaged in the marketplace. So if you think about it, all of this is leading in one general direction. The idea of DevOps and microservices and these ecosystem challenges lead us to increasing our speed, reducing our risk, and that increases our opportunity. The organizations that can make sense of this, the companies that know what tools to put in place, that are going to help them do a better job of monitoring, a better job of releasing, a better job at agility, a better job at security, a better job at connecting and routing. Those companies are going to be at the at the head of the curve. They are going to be the ones making a difference in the marketplace. Now, there are lots and lots of products that CA has that actually address this material directly. You've got lots of opportunity here and lots of really smart people in the room. So hopefully you'll get a chance to start talking about this stuff amongst yourselves and coming up with some great ideas on how you can start to apply the lessons of DevOps to start to reap the promises of microservices and meet the challenges of the API ecosystem. I want to thank you very much. I've had to have this opportunity, and I hope I get to see you when I visit later this year. Thank you.